Welcome to the next part of the 2016 Maths Methods Unit 2 Exam 2, or the Technology Active Exam for Semester 2 of that year. Okay, now, because I use my exam time wisely, or my reading time wisely, I know that I'm not going to answer any probability questions. Question 1 is a probability question, question 2 isn't, so I'm going to answer that because there's some gimme marks in there. Now, so unfortunately, the number of Carlton supporters in the western suburbs has been declining since 2012 due to lack of success and nefarious dealings. Ironically, I think Hawthorn supporters have gone up, but, 3 in a row isn't bad. The number of supporters N can be modelled by this, where N, naught, and K are constants, and T is time in years from the 1st of July 2012. There were 27,000 supporters when the model was first applied. So, N naught, if you can remember what that means that's our N at the start. So with this one, N naught 27,000, you'd write it down. For some working out, you would say, let's see, let's say 27,000 equals N naught times 2.7 to the power of 0. And just tells us that 27,000 equals N naught, because power of 0 equals 1, N naught is 1, so that's it. N naught is 27,000. Okay, after 1 year, the number of Carlton supporters is 21,600. Oh no, they have declined. Find the value of K. Give your answer correct for decimal places. Okay, so with this, we're just going to substitute some values, and we're going to solve for K. So we're going to say, so I'm going to go up to this, yes, and I'm saying solve, and it's not 27,000, it is 21,600, 21 and 6 equals 27,000, 2700 to the power of 1k, or just k, because it is 1 year, and we're solving that for k. And negative 0.2247. Okay, so that's what we end up with there. Now, during what calendar year does the membership first drop below 3,800? Okay, so now we've got a value for k. We've got a value for, and we've got a value for N naught. So we're looking for when it first drops below this. Now, there's a couple of ways we could graph it, or we could just solve. So what we're going to do, we're going to solve for T. So we're going to say solve 3,800 equals 27,000 times 2.7 to the power of negative 0.22466, so it is, and I'm typing it in there because that's the degree of accuracy I've got. That's what I want to try and keep, times T, and we are solving that for T. And I'm pressing enter, and we've got T equals 8.78. So it's going to take 8.78 years. Now, 8.78 years. Let's have a look. So we're looking at 2000. Now remember, our thing started in 2012. 2012. So it's halfway through 2000. So it's 2012. So if I say 2012.5 plus this, I'm going to delete this here. Tell me 2021.29. So it's time it's happening in 2021. So drop below 3,800 in the year 2021. It's not looking good for Carlton. So they're the steps that you take there. For that 3 marks, you'd put that in, you'd have that. We'd want to see that you know how to set up your equation. We know that you are solving for T, and that's the way you'd go about doing that. And then you got the added pressure of realizing that it's 2012 plus 8.78, but it's 2012 and a half, because July. So it's a tricky question with a little bit there going on. Okay, let's see. Do I say C? Oh, no, we're going to sketch this thing. So, and it gives us a domain over which to sketch it. So we're going to go over here and we're going to sketch it. Now, ideally I would have defined it. So if I define n of x equals 27,000 times 2.7 to the power of negative 0.22466 x, and we are saying given that 0 is less than x, or less than or equal to x, and then x is less than or equal to 10. So now time is done. I'm going to graph it now, and I'm graphing n of x. I'd love to do n of t, but it's what our axes are, n of x, and it's not there, and that's where we get problems as well. So we're going to, now we can't see the graph. We know that we're up at 27,000, so I'm going to change my Windows settings. I'm going to set my x min to say negative, I don't know, 5. I'm going to set my x maximum to 12. I'm going to 10. I'm going to set my y minimum to negative, say, 100. And I'm going to set my maximum to 27,500. Let's have a look. And there it goes. So we know we've got our two endpoints. This is label endpoints using accordance to the nearest integer. So we know this is 0 and 27,000, and this one here is 10. And let's have a look. So we'll say we're going to go back to this. We're going to solve for n of 10 to 2,899. So I'll say over here. So this is 0 and 27,000. This is 10 and what was it? 28.99. 28.99, and that's the way I go for that one. Okay, now that's D. Now we ask you to do E as well. By considering chord joining the no, we're not doing that. That's calculus. I don't know if I wrote A or E or C, but no, you're not doing that one. All right, let's have a look at question 3. Let's see if we can answer question 3. Oh, here we go. It's a question. It's a practical application of cosine function, trigonometric function, circular function, whatever. Temperature inside a computer lab is controlled by an air conditioning system in such a way that the temperature in degrees Celsius at any time t hours after 3 a.m. is given by the rule this. State the amplitude of that. So once again, I'd be going, let's make a new calculator. Let's close this in fact. No, let's make a new calculator page. We're going to define this. C of x, we're calling it, because C of t, C of x, 22 equals 22 minus 4 cos of pi times x over 12. You've got to put in that times x, otherwise you get pix, and pix is nothing. So we got that, and so we just check to make sure it looks like what we've got here. Yep, okay, looks about right. Okay, so from there, we're stating the amplitude and the period. Okay, well the amplitude is going to be 4, not negative 4, it's 4. And we've got, and our coefficient is pi over 12. The coefficient of x is pi over 12, that's our value for n. So then the period, t, so we've got 2 pi over n equals pi over 12. So we are solving for n, are we? No. 2 pi over, 2 pi over pi 12. So we're going like this. This tells us that period. Period is 24. So 2 pi over pi 12, 24 hours. Okay, so that's what we end up with there. Sketch a graph of this for the 24 hours, labeling any endpoints and turning points using coordinates. Okay, so we're going to go for that. Now we're going to redefine this function. We're going to say we're given 0 is less than x, and x is less than or equal to 24. Let's just check. That's what we're actually doing. 24. Yep. Okay. So now we're going to graph this. That's what it tells us to do. We're graphing c of x. Once again, we're not seeing it because, hang on a second, it's not right. Oh, we got out to 22. So So menu, analyze graph, no, we want window settings. We want to go to 26, I say, so try to say 27, we're going to go down to 7. No, starting to get confused, I'm starting to try to rush it. We're going to go from -1 to 25. My minimum is going to be 18. We'll go 16, and our max will be 26. Let's see what that looks like. So there we have it. I'm just going to move this a little bit. Okay, so we've got our endpoints and turning points. So we can label our 2 endpoints as being 0 and 24. So let's go back to this. C of 0, 18. So 18. So 0 and 18. C of 24. It's also at 18. So there's our 2 endpoints labeled. And then because of cos graph, and we know that these graphs are symmetrical, we know we're looking at the halfway point. If it's 24 hours, we're looking for cos of 12. There's our turning point at 26. We can then check that just to make sure. Menu, analyze graph, maximum, 1 there, 12 and 26. So we could have done that graphically, we could have done the way I did there. The reason I chose to do it like this to find our maximum point was in case I didn't get a neat answer, if I had got a fraction or something like that. This way will give you fractions. If you do it here, you will not get fractions. Okay, so that's question 3 done. Question 2 is done as well. I'm going to stop here, and we're going to have a look at question 5 and maybe 1, but we'll see how we go.